Metal mold processes where you're talking about a permanent mold where metal flows either under gravity or under low pressure or high pressure. Okay. But the really interesting part of this lesson is how do you compare processes and how do you select the right process. I want to come to that quickly. Now die casting mainly for aluminum, magnesium and zinc alloys where aluminum is the king. Most of the die processes are using aluminum. And within that, if you see by weight, pressure die casting takes the cake. 50% of aluminum alloys in metal molds are produced by pressure die casting, followed immediately by gravity die casting at 30%. LPDC is not very popular. It's in between both. It has the best of both worlds, but not really. People really go for more for HPDC or GDC. Here are some pictures of a wheel plant in Haridwar. This is the Rockman foundry of Hero Honda, earlier Hero Honda company. And you can see actually a wheel casting being poured. Okay. That's the machine shop. For those who have not seen a foundry before, it can look as nice as this, so don't get worried about foundries. The foundries where you can go with a white coat and come back with a white coat, no problem. So there are very good foundries in the country are available today. I'll skip these. Only one interesting part of in GDC, you can combine GDC with a metal mold with a sand core. So if you want to get in aluminum a complicated passage, you can put a sand core there, and this is called a semi-permanent mold. So mold is permanent, but core is expendable. So it is like a combination of metal mold and a sand core. It's possible to do that. Now different processes have different capabilities, and here is where the designers have to choose the right process. Because choosing the right process and designing a part, or designing a part and choosing the right process are a chicken and egg kind of a problem. Okay. Why? If you look at maximum weight, okay, you can see comparison of normal green sand casting, investment casting, GDC, and then your PDC. Okay. But if you keep coming down on that, and if you look at, let's say, minimum wall thickness, remember these are generic values. A particular foundry in Gujarat says, oh, I have produced up to 0.75 millimeter minimum wall thickness in investment casting. So every foundry has their own different limits. So these limits are generic limits and safe limits. You can go below this or above this depending on your foundry. So when you look at minimum wall thickness, if your wall thickness is of the order of 1 to 2 millimeters, and if it's steel, you have no choice, you have to go for investment casting. If the wall thickness is, let us say, 3 millimeters and it's aluminum, you can think about PDC. And if your water size quantity is large, you can think about PDC. Okay, you need to really look at combinations like that. Dimension tolerance is becoming very important. Most castings or many castings these days are machined on CNC machines, and their dimensional control is very important. You don't want to start the tool, and these are high speed machining sometimes. Tool approaches at a high speed or cuts at a high speed. Suddenly you don't want an additional thickness because of a dimensional tolerance gone wrong. Your tool will break. So the tolerances are becoming very important. So is the surface finish. Ideally you don't want to machine the casting, you just want to use it directly. Maybe just machine the mating parts and leave it at that. Okay. Then the quantity of economic quantity, the minimum order size, okay. The lead time to make the tooling and the samples ready and things like that also are important. In investment casting also is important because you need to make a die in which you make the wax pattern to make the investment casting. So these tables, which are again generic, you have to redraw the tables for again your foundry and your cluster and your segment of the industry. Then you can know exactly how to leverage the capabilities of the product and process. This was what I want to show it to you.